Dear students, good morning. Today we discuss the Poisson distribution. Poisson distribution is one of the discrete probability distribution. It is a limiting case of binomial distribution. So before going to that, what do you mean by binomial distribution? Binomial distribution parameters are n and p. From the n and p, we are applying some limits. N tends to infinity and p tends to 0. It is converted into Poisson distribution. Okay, that is called as NP is equal to lambda. Okay, lambda is one of the great vector. What is the definition of Poisson distribution? A discrete random variable x is said to follow Poisson distribution if it assumes only non-negative values and its probability mass function is p of x is equal to e power minus lambda power x divided by x factorial, x tends to 0, 1 to etc. Okay, now we want to find the value of mean and variance of this Poisson distribution. So we can use this probability distribution. So probability distribution is summation x into p of x is a formula for that, right? So using the moments function, we have to find the mean and variance. So what is moments? Mu1 dash is equal to expectation of x. That is called as mean. That is equal to summation x is equal to 0 to infinity x into p of x. Okay. Now instead of p of x, we have to apply the Poisson distribution. Here we are applying the Poisson distribution formula. Now we can see here e power minus lambda is a constant, so we are taking outside. So what is the remaining if you are taking e power minus lambda is outside means e power minus lambda summation x is equal to 0 to infinity lambda power x by x factorial, right? Now from this we can see this x is there in the denominator, and in the denominator x factorial is there, in your numerator x into lambda power x is there. Okay, so the x we need to cancel, so that's why the denominator we can write like this x into x minus 1 factorial. Now you can see the denominator and numerator x is cancelled. Okay, so what we have to get lambda x only we will get, where lambda x divided by x minus 1 factorial. Now the denominator x minus 1 factorial is there. So lambda power x we have to split lambda into lambda power x minus 1. So if you are taking lambda is outside means we get summation I x is equal to 1 to infinity lambda power x minus 1 divided by x minus 1 factorial. So this one if we are applying 1, 2, 3 like that, now we can apply 1 instead of x lambda 1 minus 1 is 0, right? Lambda power 0 divided by 0 minus 1 minus 1 factorial, that is only 1, right? So what will we get? 1. So see the first one 1 plus if you are applying 2 means lambda square lambda 2 minus 1 divided by 2 minus 1 factorial means we will get lambda by 1 factorial. So like this if you are applying 1, 2, 3 means that the equation will be extended. Okay, that equation is like the e power lambda, right? That is a binomial expansion. So if e power minus lambda and e power plus lambda is cancelled means we will get only the lambda value, that is called as a mean value. Okay, so this is a mean. Mean is equal to lambda. Now we have to find the variance. Okay, so before going to that, what is the variance formula? Mu2 dash minus mu1 dash the whole square. Now we want to find the mu2 dash. So mu2 dash formula is expectation of x square is equal to summation x is equal to 0 to n x square p of x. So in this x square, you can expand this like this x into x minus 1 plus x into p of x. Now we have to write two ways. One is x into x minus 1 p of x and another one is x into p of x, right? That is they write like this. Okay. Now what we have to know this, the second part we know the answer, that is nothing but mean value, right? Mean is what? Lambda, and this also lambda. So the final one we know this. Only we need to calculate summation x is equal to 0 to infinity x into x minus 1 e power minus lambda power x by x minus 1. Now we can see x into x minus 1 is there. So in the denominator also we have to write like this x into x minus 1. X into x minus 1, x minus 2, x minus 3, etc. X factorial we can write like this. So x into x minus 1 in the numerator and x into x minus 1 in the denominator will cancel means what will we get? Summation e power minus lambda power x divided by x minus 2 factorial we get, right? So e power minus lambda is a constant, so you can take outside. And what is the remaining? Lambda x. In the denominator, we have x minus 2 factorial, right? So instead of that, the numerator also, we can take x lambda power x, we can take it lambda square into lambda x minus 2. So the both are going outside means the summation x is equal to 0 to infinity. This part will be there. Okay. So in this part, we have to apply x is equal to 1, 2, 3, etc. means that comes of binomial expansion. So that binomial expansion term is e power plus lambda. Now we can see e power minus lambda, e power plus lambda is cancelled means from that what we get lambda square plus lambda will get. So lambda square plus lambda is answer for the mu2 dash. So now we come to the last term, variance. Variance is equal to mu2 dash minus mu1 the whole square. So mu1 is lambda and mu2 this one. So lambda square plus lambda minus mu1 the whole square, that is lambda square. So minus lambda square plus lambda square is cancelled means we will get variance is equal to lambda. So from this what we observe, the Poisson distribution mean and variance are equal. Both are lambda. Are you clear this?